You are welcome once again to Maths and Physics class online. Here we teach physics and maths in depth for your understanding. We are going to be looking at the last aspect of indices. We started this topic some few days back, and today we are going to be looking at the last aspects. So we are going to be looking at a situation where we have power given to a fraction. How does this power affect this fraction, the numerator and the denominator? So we'll look at it so that we'll be able to apply them whenever we are solving questions that involve indices. By our next class, we're going to be entering indical equations, but before then, we're going to be solving some simplification and others concerning indices and the expression. So if, for instance, we have a raised to power, a over b, all raised to power n. A over b, all raised to power n. How does the power that is outside these brackets of the fraction having the numerator and the denominator, how does it affect both the numerator and the denominator? We are here to say that this expression is the same thing as using this power for the numerator, which is a, going to be a raised to power n, then the power as well will affect the denominator, b raised to power n. So that is how it is. It does not mean that this power is only for the numerator. It is both for the numerator and the denominator as far as the bracket is covering the numerator and the denominator before it is powered or raised to a power. So if you have a power and you have a fraction inside the bracket and the power is outside the bracket covering the numerator and the denominator, just know that that power is for both the numerator and the denominator. So you are going to raise the power of the numerator to the power of the fraction, and you as well raise the power of the denominator to the power of the fraction. This is a different situation or a different scenario. For instance, we have this is the first situation. Let us look at the second situation where we have a all raised to power n all over b. This is different from the first example that was considered. A bracket raised to power n all over b. So this is equivalent to a raised to power n all over b. You see that the power does not affect the denominator. Why? Because the bracket is not covering the denominator. So it will only affect the numerator, as in this case. If the bracket was covering the numerator and the denominator, as in this case, then the power will affect both of them. But as it is here, the power will only affect the one that is having the bracket. So the same thing goes for if we are having a situation like a all over b, this raised to power n. So only the denominator will be affected, b raised to power n. So that is what I want us to know today. Then we are going to have some one or two numerical examples for this. Take for instance, we have 2 all over, let's call this one our example 4, 2 all over 3 all raised to power 2. 2 all over 3 all raised to power 2. So what is the equivalent of this fraction? The equivalent of this fraction will be 2 raised to power 2 all over 3 raised to power 2. That will give us 2 raised to power 2 is 4 and 3 raised to power 2 is 9. So 2 all over 3 all raised to power 2 is equivalent to 4 over 9. So let us have another one. We're going to apply what we just learned in our last video, the negative power, which is a form of reciprocal. We're going to bring in that negative power now. So let us see how we're going to manipulate and apply it in this situation. Take for instance, we have 2 all over 5, all bracket minus 2. 2 all over 5, all bracket minus 2. You consider that it is no longer just positive power, it is having negative. So it is a negative power. We said the other time that when you are having negative power like this and you are having a fraction inside a bracket, you see that this negative power is for all the fraction inside. What happened? The denominator and the numerator will exchange position, which will now make it 5/2. So the negative is acting on the fraction. This negative acts on the fraction. Instead of 2/5, it now becomes 5/2. But the power remains the same, bringing the 2. The negative has done its work by turning the numerator and the denominator. So the power remains there. So that will be equal to 5⁻² is 25. And 2⁻² is what? 4. So you see that I'm using this power to operate the denominator and the numerator. So 5⁻² means 5 times 5 in 2 places. 2 in 2 places, 2 times 2, 4. 5 in 2 places, 5 times 5, 25. So that is what we are going to be looking at today. And have it in mind that we have just treated that when a power is introduced to a fraction and the power is outside the bracket that covers both the numerator and denominator, the power will affect the numerator and the denominator, as in this case. But if it is not, the bracket is not covering all of them, it will only affect the one that has the bracket. So we have numerical examples that we just considered. Thank you very much for watching. Please do like, comment, share, and follow us on this page and our TikTok account. You also follow us on our YouTube channel. When you do this, you are going to be getting our videos once they are posted. Once they are posted, you get them, and you as well follow us and learn a lot in this class. Thank you for watching. Please do follow us, and please do share these videos for others to benefit.